All right, what's going on, folks? Can you guys hear me? Awesome. Awesome. So here's what I'm going to do. I'm going to open up a Google Doc, and I don't have a computer that I can type on, so today I'm going to have to teach you by typing things out. That is the additional challenge, but I'm up to it. I'm ready for this. Are you ready for this? Because I'm ready for this. How's it going with you? Don't play any April Fool's pranks on me. Um, did you guys have any good April Fool's pranks that you played on anybody? Or played on you? What did you do? What did you do? I'm curious. Hey, what's going on? So what did you do for April Fool's? Did you do anything? Yeah, essentially we only got girls today. I changed all the clocks in the house and on the phones until my friend was 12. Ah, that's so good. That is so good. I like it. Slightly unnerving, but very good as well. I mean, you don't want to be mean about it, but I like that one. All right. I should do that at the office over here. I'll go and change all the clock. Well, I can't go into everyone's computer. Yeah, that doesn't work. Yeah, I should do that at the office. Like, sit at the clock and you're like, called her back at home and figured it out. Oh, okay. All right. That's pretty good. All right, let's see. All right. I'm making up stuff off the top of my head. Let's do 10. Oh, excuse me. Sorry. All right. I'm gonna do x squared plus okay. So check this out. You ready? I have a bunch of these kinds of problems, and I'm going to go back to factoring. You guys remember factoring, where you guys have those two sets of parentheses, like that? So let's factor these. Okay? And you know what I'm going to do is I'm going to change a couple of these to minus. Okay. So for the first one, I want to factor this. Got it? And I'll tell you what, if you guys want, I'll share this Google Doc with you. This is 2015 0401 Algebra 1B class. There's no point really in me sharing this with you, but you can jump in on the Google Doc if you guys want. Next one here, jump in on that Google Doc. I think that'd be pretty fun. So click on that link, go into that Google Doc. Let's work on it together. All right. I got an unknown crocodile, an unknown capybara, a raccoon, a rabbit. All right, cool. So go ahead and click on this, and here's what I want you guys to do. Fill in this thing. Factor that for me. I know that I'll get you started. We're going to have an X here, an X here, and an X here. And I know that there's going to be a plus in between each of these. Right? We're cool with that. Now, tell me, what numbers are supposed to go in there? Justice, go and click on the link I gave you guys a couple, lines back here. I'll give it to you again. Go and click on this link and jump into the Google Doc. Somebody go in and fill in the numbers there. Come on, somebody. 6 and 9. No. If you put in 6 and 9 and you try foiling that out, that won't work. It needs to be in two numbers that multiply out to be the number 9, but add to the number 6. All right, Colette, jump into that Google Doc and put it in, please. Come on. Oh, I get it. I see what's going on. Try jumping to this link right here. I don't know if it's different. Try jumping into that link, because now you can edit it. But previously you couldn't edit it, I think. Can you guys edit it now? Awesome, awesome. Thank you, Anonymous Narwhal. Yes, 3 and 3. Very good. Okay, cool. Let's do the same thing here. Whoa, no, not that. I want x plus. Give me a second. Don't edit it just yet. Don't edit it just yet. Give me a second. All right, go for it. Edit this one. What should go here? What should go in these numbers right here? 2 and 2. Awesome. Very good job. Okay. This would actually be minus and minus. All right, Narwhal, you've actually answered a few of them. Somebody else answer. Throw it up there, you guys. Come on. Is that a lion? A liger. A lion. A what? Axolotl. Badger. Narwhal. Rabbit. Moose. Okay, fine. That's cool. What we're doing right here, Justice, is we're factoring. I'm glad you threw that out there. We're factoring. We're going back to like quad 5, you know, and we're factoring these things down. You remember this stuff? Somebody throw up your answer. What should go over here? What numbers should go over here? Remember, you're looking for two numbers that multiply out to be 16 and add up to be -4. What two numbers multiply to be positive 16 but add up to be -4? Ah, there we go. Very good. Very, very good. Awesome. You guys got this, right? Like, this isn't even that hard anymore. Justice, I want you to tell me. Justice, I want you to do this one for me, okay? What two numbers multiply out to be 25 and add up to be -10? You have to tell me two numbers that when multiplied together you get positive 25, but when you add them together you get -10. Can you think of them? This one's actually pretty straightforward. There we go. Good job, Badger. I don't know if that's you, Justice, but good job. Good job, whoever the Badger is. Awesome. All right. Try that one. What is this one? Awesome. Now, everyone, put your mouse where my mouse is, so we can get everyone's cursor off the screen. Who's the liger? Liger, put your mouse where my mouse is. Okay, fine. Don't listen to me. Okay. So check this out. Here's what I want to do. All right. You guys all know how to do this, right? Can you see the pattern? Can you see, what can you tell me about these factors? I chose these numbers very specifically. What can you tell me? They're the same. That's what you can tell me. All right? What I mean is, like, the two numbers are the same number. You're going to choose 3 and 3, or 2 and 2, or -4 and -4, or -5 and -5, or 1 and 1. They're the same, right? So essentially, if I have x plus 3 times x plus 3, I could write that as parentheses x plus 3 squared, right? Just like I could write this as x plus 2 squared, or x minus 4 squared. You get it? All right, you sure? Because I need you to understand this. I need you to understand that this math that I'm teaching you is not magic. I'm not pulling it out of my butt. I'm showing you where it comes from. And I feel like, one second. Check. 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 Can you guys hear me all right? The audio cut out for just a second, but can you hear me now? Awesome. Okay, good. So, check this out. Looking at this thing, I feel like you guys understand this. Basically, I gave you a problem to factor. You guys factored it. I chose the numbers very carefully, what numbers I want you to factor, because what I wanted to do is the numbers that I chose were these things that where you put in the same number. So we could write it like this. So all of these three different things say the same thing. If you don't believe me, FOIL this out and you'll get this. Or actually FOIL this out and you'll get this. It's all the same. Are we cool with that? If so, say cool. That way I know you can hear me. We gotta hurry because we're running out of time. All right, awesome, good. So check this out. Here's the thing about completing the square. This is the hard part. This is the hardest thing we're gonna be doing in this whole chapter. And I told you this chapter is huge, super important, all right? What I wanna do, and I'm gonna give you guys maybe 3 minutes, and I know that this is a long time, but I'm gonna give you 3 minutes. I want you to take a look at these numbers, all right? This number, and this number. 6, 9, and 3. Or 4, 4, and 2. Or -8, 16, and -4. I want you to take a look at those three different. You know what I'm going to do is highlight them. Let's see. That number, and that number. In fact, I'm gonna give it a general form. I'm gonna say, all right, x squared plus bx plus c, and then you can factor that down into, like, I don't know. I'm gonna just call it x plus k squared. So I want you to look at this number, and this number for all of those equations. And tell me if you could see some kind of relation. Can you guys see it? If you see there's some kind of pattern that is emerging between all those three different numbers. Say yes, no, kinda, I don't get it, I don't understand what you're asking. Tell me your thoughts. What's going on? Okay. Laura, I'm going to give you, since you said yes, and I appreciate that yes. I'm not calling you out and putting you on the spot. Can you kind of like start typing up what your thoughts are? Okay, all right. 9 and 6 can be divided by 3. I like where you're going with this. I like where you're going with this. Awesome. Yes, that's true. 4 and 4 can be divided by 2. Yes, that's also true. -4, -8, +16, those can all be divided by, -4. 8 and 16 can be divided by -4. Yes, that's also true. Yeah. All right. Here's what. Let's go off of your idea, Laura. Okay. Take the number b. So take whatever number's in the middle and divide it by, this number k. What do you get? Take all of those numbers and divide it by. So take 4 divided by 2. Take -8 and divide it by -4. Take -10 divided by -5. What do you get? Come on, you guys. 2. You get 2. That's interesting. The way that middle number is related to this number over here is by 2. Okay. Now, let's see if we can work on this number at the end. 9, 4, 16, 25. Do those numbers look familiar to you? They're a part of a special set of numbers. I'll tell you what those set of numbers is. 1, 4, 9, 16, 25, 36, 49, was it 64, 81, 100, 121. Yeah, exactly. Those are the perfect square numbers. In fact, this thing right here, this thing times itself will give you the number 9. Or 2 times itself will give you 4. Or -4 times itself will give you +16. All right. So we're seeing a pattern here. We're learning. See, that's the thing. I never want to be the kind of teacher who pulls things out of his butt and say, learn this for the rest of your life. I want you to discover it for yourself. I think it's interesting. I think we're getting somewhere here. All right, so I'll tell you what. Here's what I'm going to do. I'll do this. I'll say, how's about this? X squared plus blank x plus blank. And then it factors out to x plus x, I don't know, minus 6 squared. What are the 2 blanks that I need? You see what I'm saying here? You guys should be able to fill this in. What are the 2 blanks that I need to put in there? Come on, you guys. I showed you the pattern. Now we're going to go and see if we can do this. Can you guys still hear me? The last one is 36. Yes, very good. 36, awesome. You're right. What's the middle one? 12, close. Not exactly correct. -12, perfect. Everyone see that? Okay. So, now I'm going to give you an even harder task. You guys ready? Okay. I'm going to say x squared plus, let's see, let's go with minus 6x. Let's go with minus or plus 10x plus blank. And I'm going to go x plus blank squared. All right. This time, I'm giving you, before I gave you k and I asked you to find b and c for me. This time, I'm giving you b and I want you to find k and c for me. All right, so Laura, you're saying that this number is 5. Is that what you're saying? And then you're saying this number is 25. Everyone give Laura a round of applause. Say congratulations or whatever, because that is awesome. You got it. Exactly. In fact, not only is it so awesome, I'm going to actually type up the rules. If you're given B to find K, you simply, what? What do you do? If you are given B to find K, you simply do what? Take B and divide it by 2. Right? Is that what you say? Everyone agree with me? All right. After you have found K, you can find C by squaring K. Do you understand? I mean, I just made up those rules based off of what Laura said. Everyone agree? Did I type up an accurate version of the rules that you came up with? Awesome. All right. My friends, you have just completed the hardest part of this chapter. That is what we are doing. This entire chapter, for the rest of the chapter, all we're going to be doing is we're going to be given B, and we want to find C and K. That's what this whole thing is about. Now, I could give you the formula, but I mean, essentially you came up with it. Let's go back to this PDF and take a look at what they're asking us to do. They're saying x squared plus 6x plus what? And what they want to do is they want to make this into a perfect square, and they say, darn, I wish this had a very specific number right here in order for it to be a perfect square. And the question that they're asking is, what number should I put in here in order to make this be a perfect square? So what it goes in this blank right here? You tell me. I've got x squared plus 6x plus what? What should go in there? 12. No, 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 no. Not 12. 9. Exactly, Jillian. Very good. How did you get 9, Jillian? How did you get 9? I want you to repeat your process, because I feel like everyone else understands it, but I want you to repeat it because that's the rules that we follow. Go for it. Type it up. I'll take my time. Or I'll let you take your time. But I want you to do it quick. And you know what? I'm not going to put just Jillian on the spot. Somebody else answer for me. How did they get 9? How is 9 the answer? Where did that come from? Someone please type it up. I divided 6 by 2, and that's 3. And then I squared that, and I get 9. Very good job. You take this number in the middle, you divide it by 2, then you square whatever that number is, and that's what you put in here. Exactly. And if I were given that equation, x squared plus 6x plus 9, then what I can do is easily factor that into x plus 3 squared, right? You guys can see that. I mean, we did that at the beginning of class. Yeah? Good? If you're good, say good. Awesome. Okay, good. That means you can hear me too. So, check this out. Let's do this one. This one's hard. Not really, but what number should go in this blank? What number should go right here in this blank? 16, exactly. You take 8, you divide that by 2, you get 4. 4 times 4, 16. Perfect. What number should go in this blank right here? $25. Exactly. There we go, Jillian. You're on a roll. So that's what this whole homework set is about. What number should go in this blank right here? $49. Very good. Awesome. Okay. All right. I got a tough one for you. What number should go in this blank right here? That one's a little bit tough. Use a calculator if need be. All right. What made that one harder than the other ones? Very good, by the way. Awesome job. What made that harder than the other ones? It's not a whole number. Exactly. If the b value were an even number, then it's easy for you to divide that by 2, right? But it's not. It's 13. So really what you have to do is you have to take 13. You have to take 13, right? Divide that by 2, and then square it. All right, deal with it. You just got, I mean, you have a calculator on hand. What's the problem? How come you're complaining to me? You got a calculator, do it. It's still going to give you the right answer, 42.25. Sure. It's not as pretty, but it works. You guys get it? You guys see it? So you guys complain, wait a second, that's not an even number. Okay, deal with it. You've got a calculator. How come you complaining to me? I mean, I would be much more upset if I were doing this like 100 years ago and we didn't have calculators. So check this out. Here's what the cool thing about completing the square is. Let's go back to this vertex form. You guys remember this thing right here? This is this is quad 2, 3, and 4. This vertex form is super useful, right? Because this tells me, drop the parabola down by 8, stretch it vertically 2 units, move it to the right, move it to the left 6 units because of that positive 6. I know how to graph that parabola without even using a calculator. I can draw it up on scratch paper for you real quick, right? You guys remember this? This parabola, drop it down by 8, move it to the right 12 units, stretch it vertically 7 units. This parabola. Drop it or push it up by 5 units. Move it to the left 8 units. And stretch it vertically 3 units, and then flip that sucker upside down. Do you guys recall this thing? That's the vertex form. Say yes if you remember this. That is super useful. The other form that I gave you was the standard form. Not useful, not very useful at all. The only good use that is, we can use that for is finding the y-intercept. But beyond that, it's not really that helpful, right? You remember that? So here's what completing the square does. Is it will help you take something that is in standard form and turn it into vertex form. That's what makes it so darn cool. Do you see that? I'll show you what I mean. All right? Let's see. Okay, let's try this one. Let's try this problem on this exercise. Okay, let's do this problem. Control. All right, x squared plus 4x equals 1. Write this down on a piece of paper. I'm going to blow your minds. Okay? All right. X squared plus 4x equals 1. Okay. What I'm going to do is... What's going on, Justin? Hey! What's up, dude? Give me a second. I'm actually finishing off completing the square. You can sit here if you want. And hang. Or you can come back. It's up to you. I got a guest student coming in. You gonna hang out with me today? We're gonna do a lab?
Oh, yeah, that's why I came here, so we can do a lab.
Awesome. Have a seat.
I have scratch paper, I have a calculator, I have pencils, paper, erasers.
Awesome. I'm actually finishing up a lesson with my students, and I'm actually really excited. So I might go a little bit over time, but I think that we'll be all right. You can just hang for now, or you can chime in on this if you want. All right, so check this out. Here's what I want to do, you guys. I want to solve x all by itself, okay? And in order to do that, actually, you know what? I'm sorry I asked you to write that down. I realized that they actually had a pretty good one. Let's go x squared plus 6x plus 7. Okay, all right. Okay, x squared plus 6x equals 7. Say that we want to solve this problem here, okay? Write that down. Got it? Yes, yes, no. Can you still hear me? All right, good. X squared plus 6x equals 7. What I would do is I would pull that 7 over to the left side. To do that, I would just write x squared plus 6x minus 7 equals 0. Are we good? I'm doing a separate problem here. Now, in order to solve this, what I would do is I would factor the left-hand side. I would think to myself, okay, I would have an x, and I would equal 0. And what I want to do is I want to find two numbers that multiply out to be negative 7, but add up to be positive 6. And what are those two numbers? Actually, I'll tell you those two numbers since I'm running out of time. Those two numbers would be positive 7 and negative 1. Are we cool with that? This tells me that my answer is x plus 7 equals 0 or x minus 1 equals 0, which tells me x equals negative 7 or x equals positive 1. This is not anything new. We're going back to what we've already done before in the past. Are we cool? Now let me show you the power of completing the square. The awesomeness of this thing. By the way, can you guys still hear me? All right. Did you guys watch me do a problem? I'm hoping that the reason why you haven't responded is because you're busy writing things down like I told you to. But do you understand what I did? It wasn't anything trickery. It wasn't anything hard. Okay, good. Now I'm going to show you the tricks. Now I'm going to show you the things. I'm going to do the same thing to this problem. I have x squared plus 4x minus 1 equals 0. All right? Now I'm going to try factoring that. X. I'm going to try factoring it, just like the one I did above. Here's the problem. What two numbers multiply out to be negative 1, but add up to be 4? Tell me. Come on, you guys. I got 2 more minutes. What two numbers multiply to be negative 1, but add up to be 4? If you don't know, say IDK. Okay, I'll give you a hint. Say IDK. Good, because I don't know either. There are no two numbers. Cannot be factored.
Or would say like unreal result if you tried to get a calculator.
No, it's not unreal results. It's just can't be factored.
Oh, okay.
These have real results. They just can't be factored. So, because, I mean, what two numbers multiply out to be 1? The only two numbers I can multiply out to be 1 is 1 times 1. Or 1 times negative 1, if I'm trying to go for negative 1. And then if I'm trying to add them together, I can either get the number 0, or I can maybe figure out a way to get the number 2. But there's no way I can get the number 4. Does that make sense?
Oh, okay. It had to fulfill both of the categories. I could think of something that would work, but
Right.
it uses numbers that aren't real.
So here's the thing. We're going to use this technique called completing the square. Now, I'm going to copy and paste this thing up here. Okay? Step 1. You know what I'm going to do? I'm going to do it in a little table. Whoa.
I'm reorganizing things so that the chair can move. It's running into old defunct electrical components everywhere.
I'm sorry. I'm a big mess. All right.
Yeah,
So step 1. Write down the problem. Well, that's an obvious step 1. Okay. Step 2. I'm going to put a really big space. Put a weird space in between
just put
the middle and end numbers. Alright? Trust me on this one, okay? You guys got it?
It's like, I have a degree. I know what I'm talking about.
Well, I know, but that's a weird step. Okay. Step 4. What I want you to do is pretend that you have this problem. What goes in the blank? What goes in the blank, you guys? This is what we were doing. Come on, you guys. 4, exactly. You take this number over here, you divide it by 2, and you square it. 4 divided by 2 is 2. Square that, that's 4. Cool? Okay. So what we should do is add 4, right? But remember, we have to always play fair. We can't just go and straight up go into that space that we added and say plus 4. We can't just say plus 4. That's not fair. Right? So we're going to add and subtract the same number. Yeah. You're only going to temporarily sit there. I'm going to bring this outside, dude. You don't need to rearrange my office. All right. We're going to track the same number. Because I have a question for you. If I add 4 and subtract 4 at the same time, what am I doing? What is 1 plus 4 minus 4? This is important stuff. I know I'm going over time. I apologize. But I mean, this is kind of important. Right? It's the same thing, right? I didn't change anything. I didn't change jack. I just said plus 4 minus 4. I'm adding and subtracting the same number. So essentially, I'm not changing it at all. Do you guys get it? So what I'm going to do is I'm going to take this thing right here. And I'm going to add 4 over here. I'm going to subtract 4 over here. And I'm totally allowed to do that because I didn't change anything. Okay?
Sorry. I really am reorganizing your things for you.
Thank you.
I just can't stand to see clutter. It's a personal tick of mine.
All right. So, here's what I'm going to do. Over here, I'm going to take this thing, I'm going to copy and paste it. Over here, I have a perfect square. I can literally rewrite this thing as x plus 2 squared. Right? I mean, that was the whole point of adding this 4 over here. Do you guys see what I'm saying? Say yes or no. Say you're following me. Come on, you guys say something. And I'm going through this painfully slow. So I took these 3 numbers and I said, hey, I can rewrite that as something prettier. I can make that x plus 2 squared. If you want to prove it to you, look, we did it up here. X squared plus 4x plus 4 is the same as x plus 2 squared. Isn't that right, anonymous moose?
Whoever that might be.
See? Look, we did that. So I just took that information. I said, oh, okay. Well, that's just x plus 2 squared, right? Factor the first 3 terms. All right. Here's the next part. Ready? I'm going to copy and paste this thing. What's negative 4 minus 1?
You want to select all of
Negative 5.
You want to select all of the text string, position your cursor at the beginning, and then press Shift End, and it selects all of it with you only having to
All right.
press 2
Okay,
keys.
check this out. There's negative 5, all right? Now, what I can do is I can do this. I'm just going to take this thing, copy and paste them. I'm going to add the 5 over to this side. So it becomes positive 5 when it comes to the right-hand side of the equation. You guys get it? Say yes or no, up to you. I apologize, we're biting into our physics time, but
It's alright.
I need to finish this with them. All right. Now, in order to get rid of the square root, add 5 to both. All right. In order to get rid of the square root, I'm going to take the square root of both sides. Don't forget to add the plus or minus. I don't know how, let me see. Can I insert a math symbol? Sure, I can insert that thing. Don't forget that thing. Don't forget the plus or minus. Alright, so, shoot. Let's go new equation. We'll do the square root of x plus 2. No, we don't even need the square root. We got x plus 2 equals plus or minus square root of 5. There we go. Everyone got that? By the way, what is the square root of 5? I don't know. 2.236? Alright, let's do that.
6, 1. 1, 2, 3, 6, 1. Don't forget that.
I'm going to copy and paste that. 2.2361. Alright, everyone cool with that? I didn't really do anything, I just figured out what I asked my calculator what the square root of 5 was. Alright, last part, solve for x. Solve for x. So all I'm going to do is I'm going to subtract 2 onto both sides. Alright, so what is negative 2 plus, or what is negative 2 plus 2.361? That would be positive 2.2361. And what is negative 2 minus 2.361? So this would be, so essentially you're doing, here we go. So essentially you're doing this, plus, minus. And then what we're doing is, okay, well, what are those numbers? That would be x equals that, or everyone agree with that? I mean, look at this. Check this out. Check this out. If I were to go to Desmos, I'm going to show you 2 cool things, and then I'm done. Give me 2 more minutes. X squared plus 4x minus 1. Okay, look where it crosses. It crosses at 0.236 and negative 4.236. Look what our answers were. 0.236 and negative 4.236. Say wow or something. Come on, give me something, you guys. Not only that, but check this out. Look at the power of this thing. We took something that was in standard form. This is standard form, okay? X squared plus 4x minus 1. And we turned it into this form right here. I don't know if you caught this in the middle. We took something in standard form and we said it's the same as this thing right here. But this right here is very advantageous to us. This right here you should recognize as vertex form. This tells me, oh, I have a parabola that is dropped down 5 units and moved to the left 2 units. You can confirm that by looking at Desmos. Look, that sucker is pulled down 5 units and moved to the left 2 units. That's what it is.
They're cheering like a crowd at a rock concert. At least only in text form.
Isn't that interesting? So what we're doing here, folks, is we're using this complete the square technique to turn something from standard form into a very useful form called vertex form. This is the essence of completing the square and the quadratic equation. Now, why were we able to use the factoring method on this one, but not on this one? And I'll tell you why. Plus 6x minus 7. All right. The first one we graphed was the blue one. The first one we solved was the blue one. But notice where those things land. It lands nicely on 1 and negative 7. So we were able to factor those because those things landed on nice numbers. But obviously not all graphs land on nice numbers. Do you guys see what I mean? Sometimes they land on ugly numbers.
Bizarre in between numbers, sometimes decimals.
Yes. So here's the thing, is if they land on ugly numbers, then you can't use this factoring form to get the right answer. It cannot be factored. You're going to get stuck. So you'll use the complete the square technique, which is why I always call the complete the square and the quadratic equation my bazooka versus the factoring method my fly swatter. And what I mean by that is this. Imagine you're trying to kill a fly, right? There's two ways you could kill a fly. You could use the factoring method, or you could use the fly swatter, and that will work. Or you could use a hand grenade. Hand grenade's messy. Hand grenade's harder. Hand grenade's uglier. But will it do the job? Your darn Skippy will do the job. It will kill that fly, I guarantee it. Well, that's what completing the square is. It's not as short. It's not as cute. But you know what? Where a fly swatter can't do it, the hand grenade will. This thing will always work no matter what. And you want to know the crazy thing? And I'm not even going to show it to you this week. I'll probably show this to you next week. Is you can even use the complete the square method when the darn thing doesn't even cross the x-axis.
Because you're just finding the n factor in the number.
This thing will even work when there are no solutions.
Because you're just finding a way to make sure the equation is whole. You're not technically solving it.
Well, no, you are. You're solving it. You're solving it using imaginary numbers and all of that kind of stuff. And we will get into that later. But know the power of completing the square. And really, here's what I really want you to understand today, is I want you to understand this rule right here. I want you to understand the rule that you guys came up with. Because that is where completing the square is. And if I tell everybody, oh, this is all you do, boom, 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 you guys be like, I don't believe it. I don't understand where it comes from. But remember, you came up with this. This was your creation, not mine. I didn't pull it out of my butt. You guys pulled it out of your heads.
Technically.
All right. I got to go. I'll talk to you later. Have fun. Okay, bye.